notice there is an ISO standard, the number is 8995, and there you can find a table with all different types. Someone was asking about restaurants. There are different level types for the counter and for the tables and so on.
I'm sorry, you need to lower your volume. People are with froze. You need to turn here, right, in this button over there.
The front?
No, on the back. The high gain. We have the gain. You need to turn this. Let's go on.
Better?
Better. How is it, guys? How is it? Let's see. How many lux does her blue eyes have?
I know. I wondered that myself.
Yeah. We just put you here that easy to make bully, you know?
Sorry for going to leave you.
Yeah, all right. I think this is cool right now. We can go on.
And now that I'm not so loud, I'm going to repeat. Standard 8995, and it is an ISO standard, so you can find a table. It's for the whole world. People were asking about the color of lighting. So just have in mind that at the end of the day and in the beginning of the day, the daylight is orangish, it's yellowish. So we are used to relaxing in that time. So if you want to relax, if you want to put lighting in a place where people are going to do relaxing activities, you want yellowish light. If you want to be awake, if you want people to be alert, then you want white light, okay? This is the basic role here, okay?
All right.
Yes. And then they ask about light density. So you don't want to look exactly about power. You want to look about for the ratio between power and lumen, because it's the amount of light that you get from that power. Okay. Every manufacturer gives you that, and you have light density. Light density is the amount of light that you have per square meter or per square foot. Okay. So the more you get, the more you're getting light in that area. Okay.
All
right. And then you have energy efficiency.
All right, guys. So
right?
Tiziana putting here the things. Tiziana, of course, she works with us at Ugreen. Tiziana has deep knowledge on lighting, on thermal comfort, on acoustics, and now we're going to proceed with acoustics actually. So this is the way to go.
Yay!
So, yeah, you can go on.
So acoustics, we talked a lot about comfort, and sound is something that we cannot avoid. So I was being loud at the beginning, and you just very quickly said, "Oh my God, turn it down," because sound is something that we are very sensitive to it. But sometimes we don't perceive it that well. For example, when we have too much noise from the street, we can get used to it, but it is slowly making our lives worse. Okay, so we have to pay attention to that. This is why we're bringing to you first an analysis of what you should do to look for the noise that comes from the outside. Okay, we know you are interior designers, but the space you are designing is not isolated from the surroundings. So you have to know what is going on outside, so you can have the proper strategies for that. Then we are going to talk about the sound inside the environment, how you can improve that, and then a little bit about HVAC, background noise, and sound masking. And we can go on.
We are going to talk about this for effects, right, inside our environment. So,
some people are saying that it's still a little too loud. If we can adjust just one more time. And some are saying that it's fine, so let's just adjust here a little.
We are just
excited.
we are just making this for you to make understanding parts of acoustics.
We made a point, right?
Yeah,
we just made a point.
It's all part of the plan.
It's all part of the plan.
Let's go.
Is it better now?
Yeah,
yes, let's go.
For us, it's cool. So, noise outside the environment, you can go on.
Thank you, guys. Let's focus then. Okay, thank you.
Okay, so we have three things to have in mind. The first one is the noise source. What is the noise source? It's where it comes from, of course. So it can be the traffic, it can be maybe kids playing outside. Sometimes you're just very near to a playground, or maybe a school, or maybe a place where they do concerts and so on. So we have to have in mind first the type of source, and then when does it happen? Because if it's a place for concerts and you're doing the design of an office, they're not going to work at the same time, so it's not really a problem. Then we have to think about barriers. What is going to help us reflect the sound away from the environment that we are designing? And then we are going to work in the envelope of that space or inside it, okay? But let's just focus on this outside part first, okay? Very important to do these diagnostics, very important to know what you're dealing with. Then we can have additional strategies from landscape design, but mostly all of these professionals are involved in this analysis, okay? So,
all right. We have here, you need to screen as well. Go on.
Sorry, I have to screen?
You need to screen collective share or something like that.
Collective share!
To this, yes.
Yay!
This is the way to go. So, you just made a question, how you know how to measure the amount of noise in the region of your project, because you need to measure this, and you need to know the strategies to do this right there. So we want you to know if you guys know this, because you're going to learn this, of course. We won't hide this for you.
And a person, while you're sharing here, I'm going to answer a question. How is this related to sustainability? Well, sustainability is about people, the environment, and so if you are affecting people, you need to bring comfort, health for people. This is sustainability. Sustainability is 3 pillars. It's not just the one caring for the environment. We are caring for people, and we are caring also for our economy. So these 3 things, they need to work together. If you are just looking at one part of sustainability, you're giving this a bad option, right? Because then you're leaving behind other things. We need to look at things holistically. And so when we're talking about comfort, health, this is what you're bringing to people. It's quality of life. So it is something that you need to bring in a normal project, yes. But when it comes to sustainability, we're talking about then acting on this with the purpose of health and wellness, but also we're going to be talking about that you're interested in material choices and efficiency. What is the efficiency of this project?
And actually, if you think in a very practical way, if I have too much noise outside, I'm going to close my window, and then it's going to be hot inside. I'm going to turn on my air conditioning, and then I'm spending more energy than I should, and the air quality in my space is lowered because of noise. So it's all connected, okay?
Yeah.
Yes.
So people may ask, this is an interior design course, of course. It's more than interior design actually, because you are learning things to make your interior design. You need to remember the first class. You need to understand the outside to make good inside, right? In your interior design. So if you know there's a lot of noise, you will get this information to make an outstanding interior design, because you need to, of course, think about this important subject. So TC, what is lack? I want to know.
Um, lack is the definition is how you measure. It's the metric actually for sound intensity. Okay, so there are more, but this is the main one. Okay, if you want to know the intensity of the sound where you are, you want to measure the LET. So it's the intensity, the equivalent intensity. Okay, so you measure it in a time span, and then you have how many decibels you get in that area. Okay.
This is not lack, TC. You know, this is not.
Ah, Mike, no, you're not going
You are
to.
telling the wrong thing. This is not really what lack is.
Lack is a song.
Yeah,
Is that what you mean?
lack is also a beautiful song.
Oh no, are you going to sing?
No, I'm waiting for you to sing this.
Ah, okay, so it's a very popular song in Brazil from several years back, and they used to sing like, oh my god.
He's doing it. He's looking.
Yeah, this is a Brazilian song, a very cool Brazilian song. You are learning lots of Brazilian culture here, Sepultura, and now.
And some people were probably here in the last event because they are already commenting with the song. They are putting there, like it.
Yeah. This is the real lack, guys. We are just joking here. All right, let's go on. I'm joking,
Yeah.
but this was very important for people to know. Let's go on.
Yes, and you can measure the sound intensity with your phone, with some apps, but they are not really accurate. Actually, they are less accurate than the Lux meter that we were talking about. Okay, so if you want to really have an analysis on sound, you should use sound level meter, but it should be calibrated. It means that the results are really accurate with another device that tells you that the result is certain. Okay.
Exactly. Let's go on. So this is our two equipment. You can have it in your cell phone. I will actually work on look for this while you are talking. Okay, so people can see on the cell phone how it works. All right.
So LEED certification is an environmental and energy efficiency certification for green buildings, and they also add this part of acoustics, but mostly for schools, okay? Because this is a very sensitive space for noise. So what they say is that if you have too much sound intensity, too much noise intensity, and that means above 60 decibels during the peak hour, it means when there's more traffic outside, say 7 a.m. or maybe during midday, and then at the end of the day, and it's the time where the school is working, where people are learning there, then you have to take measures to not let that sound get into that space, okay? And this is what you see when you have an app for sound, okay? But again, it's good, just like Lux meter, it's good for you to have an idea, but don't trust the number, what they are telling you in terms of decibels. Do it as a qualitative measure, okay?
Exactly. Cool. Let's go on.
And then when we talk about barriers, we want to keep that noise outside. We have to have something in mind. This barrier has to be as close as possible to the source and not to the building, okay? And what you see on your screen right now is the effect of sound called diffraction, okay? I don't know if I... Speaking that right, but what you see is that the source comes from the upper left part of the picture, and when it gets to the barrier, it is reflected back, okay? A part goes through, goes over the barrier, and a part is reflected. If it's close to the source, it will reflect more. That is the key here, okay? And also the size of the barrier. The tallest, the highest, the more it will reflect, of course.
Exactly. All right. I'll just put a cool commentary here, right? As we said, Marina is standing here. You need to use professional equipment to make it professionally, but you can have an idea with this software,
Yes.
right?
When we talk about apps here, guys, like I said, with the Lux, you're relying on your cell phone camera, and with this one, you are relying on the microphone. So the technology of the phone will play a role too. So you cannot just use this as absolute results. Have professionally measurements done. This is just for you to have an idea and start, something, but start a conversation, would say, with your client.
Yes, and then you may ask, okay, and what is the deal with vegetation? Does vegetation work? Does it help? It does, as long as you have density, as long as you have different types of vegetation in that area, because you need that density to hold the noise, that doesn't let it go through all the gaps between them. This is why diversity in vegetation is also important, because then you have different heights, and the leaves and the trunks will help hold that noise. So what you get when you have 30 meters from the source to the receiver is 5 to 8 decibels reduction. It's not, it's sensible, but it's not what we would expect. So you need 30 meters of vegetation. In the next slide, in this next slide, we add the topography. If you have slopes, then you have mass, and this mass will help retain more of this noise. Then you can have a reduction of 10 to 15 decibels, okay? So this is something very important. Vegetation needs to be dense and needs to be diverse in every way in sustainability, but also in acoustics, okay? I know there are some landscape designers here, so you have to have in mind, okay? So sound insulation is for preventing the noise that is outside to entering in your environment. And that means that it's not only out of the building, but also the next room from where you are working. For example, if I have a corridor and there's noise in that corridor, it's an outdoor environment from my environment. So I want to have this care with the insulation as well, okay? But we also what do we use to avoid noise coming into the environment? So we have to insulate. We have to avoid small spaces where the noise can enter. So if you have plasterboard partitions, you have to be very careful with these gaps. You have to seal everything because noise will go through, okay? Sorry.
Right. No
Doors is the same thing. If you have two offices and you don't have problem with the noise, it's okay to have a simple door. But if you have this problem, for example, with the corridor, that it's a public space, private space, and your office, or maybe the door from your house or something like this, then you have to also have a door that it's preferably heavy in mass, and also when it's closed, you have to be certain that there are no gaps where the sound can go through. And I'm going to be really stressful about the gaps, okay?
Mind the gap, right?
Mind the gap. Mind the gap. As the British says, mind the gap.
Yes.
Actually, what Tiziana is saying about the leakage of sound, it can come from small places and do great damage. Like I actually discovered this when I bought an apartment. My last apartment, I was wondering why some of our bedrooms were better and other ones were not as good with the acoustic. Because the windows were all facing the same side of the street. So I was really wondering, and I actually took the whole window frame out, and I discovered that some places, the guys that constructed that apartment, they did not unify and sealed well the window with the walls. So that area was with tons of leakage, of sound leakage, and with the window frame, I couldn't see that. I had to destroy the window so I could find out the problem. So this is something that sometimes people are not taking into consideration, this small leakage or hidden sound leakage.
Exactly. All right, let's go on.
And sound insulation is something very sensitive in hotels as well. One of the biggest problems in hotels is that you hear the pipes. When someone flushes the toilet or something like this, it's very annoying. So you want to also have this kind of insulation. Here in Brazil, we have a brand of pipes that they already provide a type of sewage pipe that absorbs the sound, but you might want to have this kind of care to insulate the sound because it's really not pleasant.
Yeah, exactly.
And then we have something that the interior designers work a lot with art, which is the absorbent sealants. So we have many brands that provide this type of sealing, mostly for working environments, for offices. And this is the type of board that you get all those little small holes that absorb the sound. Okay, so this can help inside when you cannot deal with the outside noise. Okay, we're going to talk a little bit about that when we talk about the indoor environment. What about acoustic and insulation of open air theater and auditoriums? This is all about reflection, okay? This is why they do those shells. So you can reflect properly to the people who are watching that. But mostly you have a really big loss in the sound intensity because of the distance. So you have to do these shells in a very specific way to reflect it right to the people. Dividing
For
corners.
theaters and auditoriums, you also have a very specialized type of sounds. Like when you have different presentations or different purposes, you'll also have, if this place is specialized when you have for presentations for classic music. So understanding the purpose, again, you also have to have this type of acoustics when it comes to the level of auditoriums or theaters. Then you have to have a professional doing this job. It's not simple answers. Then you have a whole lot more to work with, and you can understand more. Of course, with the information we're giving you here, you will understand and question more to these professionals. But it would be nice to have somebody like Tiziana or a different company that is simulating this with a higher level of concern for all these type of sounds.
Yeah, one thing that I'd like to add as well is that you need to understand this. Depending on the volume, is going to have different standards. So you're going to have NC60 for most of this. On volumes, you need to analyze the volume. It's 556 meters cubic meters. 556 cubic meters. You're going to analyze with NC60, and then when it's more than this, you're going to have other stretches to make. And we're going to show you this. Okay.
So again, as we said, we are not working alone and isolated from the world or from other professionals. So we have to check that we are not stepping or having any problem from the other teams or causing any problem for the other teams when we do this kind of care with the gaps. Okay. Right. I think that the slides just went out.
Oh, sorry, my apologies. I gotta make sure here. Let's go on.
Let's go on. Next
All right,
slide,
guys, let's
please.
go. Sorry to see. Guys, let's go. We are in the we passed the middle of the class, so
Yes.
Let's go on.
So
Right.
what do we use usually for that? The traditional construction uses a lot of ceramic blocks, concrete, cellular concrete blocks, or limestone, and so on. The thing that you want to know here is that the more mass you have, the less transmission of sound you get, okay? But other than that, you can use insulation materials, like, for example, the air can also insulate. If you have a distance, it can help you. But also some kind of wool and also wood works as well a little bit as insulation materials.
All right.
And then there's the unusual materials and also the sustainable materials. And in this area, I would like Sammy to speak a little bit more because she is the material girl.
All right, I will change the
Because
slide a
we're
little
really
bit.
the material world, so.
We can do this together, actually.
Okay.
We can talk a little bit about the materials, and you can tell me, and you can comment, from the acoustic part of this. But when we're talking about materials, we have examples of regular materials that we have, and some of these regular materials, they may have the eco version of them, and some of them are not as eco-friendly. So when we're talking about the usual materials, TC just mentioned, the glass wool, we have the rock wool, we have the foams, and usually foams and anything that has to do with polymers are not as eco-friendly, or they have an eco-friendly version. But so here you have
Show
the
guys.
traditional. Where
I'm
are
not
we
sure
at?
because
Oh, you're not sure.
it's very hard because
Okay,
lots
so
of changes. Let's go on. I will just show this. All right, now we got this.
You got it?
Let's go on.
Okay. So what we usually have as far as this unusual materials, which TC just says, glass wool, and we usually use this in drywalls. The next slide just. And the rock wool, where you have in between your concrete blocks, or you have in between the
Glass walls.
the masonry blocks too. All of this you can use with the rock wool. And here I'm talking about the traditional materials that you are using for acoustics. And then you have the rock wool that you're using in on the roofs and in different types of areas too. It is applicable. But again, this usual materials, you would have to look for their brands. You would have to investigate more of the processes. There are some eco-friendly versions, but they are not always, this is not what you will find commonly. So work with your acoustic designer to understand what do you need, and then understand what kind of materials that you need, and then what are the alternatives for these materials in the eco-friendly world. So this is a little bit of a legwork here that you have to do. Unfortunately, acoustic materials are progressing, but they are not in abundance because, again, when Chissy said, it's a subject that is very sensitive, and it needs density, it needs some material properties that would, special properties of the material that would respond to this. So this is something that is being still worked on, and one of the hardest materials for you to find as far as sustainable versions of it.
Yeah, you need to understand that every part of a building will need a different acoustic element. So like pipes stick on walls, so you need to understand this.
Exactly. When you're dealing with sounds that are bouncing, then you need a material that it's an impact sound, and you need a type of material. If it's a sound that comes with the air, it's different materials again. So this is something that it's not done in a simple way. It's not a simple decision here. But there are some sustainable versions that we can see in the market nowadays. What do we have? It's coconut fibers, cork panels. A lot of people are talking about this then and that now, and especially because Levi's bought this fight, and they are working to provide this material so we can create insulations from denim and recycle bottles. And this wool mixtures that comes from let's say the things that would be wasted in wood and wool industry, that they are using this and recycling this and creating panels. So we can show this coconut fiber is something that it's coming in a lot, especially in tropical countries where we have this abundance of materials. So again, what is abundant in your local area, and what are the technologies that are available? We have to pick our battles here sometimes because we need the industry to catch up with us. So there are these limitations with materials for certain purposes. We're not at the point where we can say I can find 100% everything sustainable in the industry yet, unfortunately. But here are some good examples. The cork panels are becoming very popular, and then you would say, okay, but cork is regional. Yes, but recycled cork, people drink wine everywhere around the world, so recycled cork can be an option. And there are some brands that are working with the recycling of cork and making panels. So then cork can be available all around the world, but check your material. Where is it coming from? Where is it being fabricated? The denim insulation, like I said, this one is becoming very popular. Some people are using it and having great results, but there are still some things to work out. This denim insulation, because it's so new to the market, they are still accommodating to the construction market. And I've read things about the panels that they don't come in a very standardized size, or sometimes when you have to cut them, denim is something that it's hard to cut. So it's something that becomes a little bit more of a work on the job site. Some brands are working with recycled plastic bottles, and I said, I'm from the beginning of the class, I said, I'm not very in favor of plastic. This brand, it's actually something that has been working strictly with plastic bottles, and they actually have a cradle-to-cradle seal, which cradle-to-cradle is a very strict sustainable seal, and they have very strict processes, and they analyze the entire process of making a product. So when you have a cradle-to-cradle recycled plastic bottles product, then I would believe, and I have seen this documentation where you actually have a good process, and they are actually taking away from the environment and creating something that will be good. And since insulation is usually within panels and within your construction, then you won't have a direct contact with it, and the wear and tear of the plastic, the chances of creating microplastics very small. And then here we have panels with a wood and wool mixture. And when we create these mixtures, we create better values, better acoustic values, because we are mixing two products. And these are bonded with the cement. And this is also a cradle-to-cradle product. I forgot the name of the brand. Let me just look here because I had it open. I think it's... Can you hear me? That usually would be going to the landfill.
We got a connection problem.
What happened?
Everyone is here? Okay, cool, guys. Everyone is alive in the spaceship. Let's see. Let's go on. I think you need to repeat the last part, and because people lost a little bit, you can go.
Okay, no worries. We'll repeat the last part. So I was talking about wood wool. Wood wool. Is that where I left off? Okay. So when we're talking about taking away things that would rather become waste, like the pieces of cloth and wool and organic cotton, and then you're mixing with wood chips that also could probably go back into the environment, but now they're creating a different purpose. We're extending the life cycle of that material that has been extracted already and becoming something really good. This product was also a product that is with a cradle-to-cradle seal. So you have versions of acoustic panels and acoustic treatments and insulation that have sustainable properties, and they have been working with materials that are eco-friendly or recycling materials and creating this other purposes and extending life of cycled materials. But then again, work with your acoustic engineer so you know what do you need, what kind of materials would respond to this, and then you start looking for the sustainable version of these materials. It's all a process.
Okay, let's go on. We have lots of things to cover, guys. We need to hurry. Lots of things to cover. We have some minutes to do this.
Yes, if you could put on that graphic, I think it sums it up. What is about all those materials that Sammy just said is that the two things you have to have in mind. This one, please, thank you. First, thickness. The thicker, the more insulation you get. And the second, porosity. The more porous the material, the more the sound goes into their pores and it loses intensity inside the pores. Okay, so this is absorption, but in this case, we're talking about materials that go inside the structure. So if the thing here that I want you to focus is this study here shows the differences between different materials. The first one, the GW, is a green wall. Okay, so does green wall work for insulation? No, it doesn't. Okay, so we see that we have a very small reduction of almost 18 decibels in this transmission of sound. Then we have brick. Okay, the A is brick, 100 millimeters thick, no finishing. Next we have lightweight aggregate blockwork because they have small cells with air inside, so they have a better insulation property. And then we have two leaves. I think I skipped something. Yes, I skipped the glazing maybe. Yeah, and the last one, we have two leaves with plasterboard, and then we have insulation material inside with mineral wool. What I wanted to know here is that for insulation from outside noise, green walls don't work. Okay, have this in mind. We're going to discuss it a little better when we talk about green walls for absorption. Okay, but for insulation, they don't really work.
Right, let's proceed.
We talked already about acoustic doors. And also the thing about sustainable materials for slabs and walls is that when you have structural noise, when you have impact noise, you have to have resilient materials. And sometimes the sustainable materials, they don't allow that. They have to go back to their original form. This is hard to get. So this is why those foams and those, I forgot the name from the first one we showed, but those rubbers, they do that. They go back, but they are not really sustainable overall. We talked about insulation of gaps, okay? And about pipes already, we covered that as well.
All right.
Pipes again, okay?
Hydraulic installations, we talked about this.
Yeah, we have to cover them. And then when we are talking about what do we see, what is the metric that we have to have in mind? It's sound transmission class, okay? STC, sound transmission class. This is the loss, this is the transmission of sound you get through a material, okay? So the noise outside is 80 decibels, and when it goes through that brick wall, then you get 40 decibels on the other side.
All right.
Right, so
the STC is very important. You have some values here. You can see, right, the table. And you can see for each space, we are going to have some STCs that are desirable. You can see residences. You can see some residences and some hotel rooms, and you can see some. You can see the combinations right between spaces and the room itself. So you're going to have these desirables STCs. So I think you should take a picture maybe, right? And then we can proceed because this is very. You need to see the space and achieve this in your acoustic, your building envelope. Okay. All right. Sound inside. So we talked about all the outside noises, right? Now we're going to talk about the inside.
Yes, when we talk about the inside, we are talking about sound quality. And depending on the activity you're doing inside, for example, if you are in a class or if you are in a concert hall, then it's different, okay? The first one, when you have to understand people speaking, we want intelligibility. We want to understand what they're saying. And when you want to hear music, then it's another way of treating that sound inside, okay? So for that, we have different materials. There is the reflecting materials, and reflecting materials are important to make the sound stronger and to direct that sound to a point where you want people to listen. This is what those shells do in these outdoor theaters. They reflect the sound to the people. And the inside, in the interior, it does that as well. But sometimes when you do have too much reflecting materials, the sound quality is lower because you don't understand people well, or the noises get too high. So for example, if you have a hard floor and someone uses high heels in your office, that might be a little unpleasant. So this is why people choose, for example, carpets that absorb the sound. And this takes us to the absorbent materials, which are the porous material that the sound goes in and loses intensity. And the last one, that is the one that does this diffraction of sound that diffuses the sound everywhere. And therefore, it also loses the intensity. So we first talked about STC, sound transmission class, the sound that is outside, the noise that goes inside. And now we are talking about NRC, noise reduction coefficient, okay? This noise reduction coefficient is the metric for the indoor sound. That's what I want to do inside, okay?
Exactly. Guys, for people who are not seeing very clearly, please refresh.
F5.
Yeah, press F5, and then you can click on the gear. We have a gear, and you need to put full resolution. And you can go near your Wi-Fi connection, get a better connection. It's going to be a better experience, okay? Let's go on. So,
and this property of absorbing sound or reflecting sound, having too much noise in the room, can also affect your privacy. So if you are in an office that you need to have very sensitive conversations, for example, human resources, you need to have this privacy. So it's better to have more absorption in those places. Or even in restaurants. You don't want people hearing what you're saying in your first date, okay? So you need to have a proper distance from the other table, but you have also to provide some sort of, some level of absorbance in the room so people don't hear you very well, okay? So there's different degrees of privacy that you have to have in mind, right?
Let's go on.
And as we said, different materials, different purposes, and you can have them all in one room. The panels in the ceiling are reflective ones, so we are talking about an auditorium. They reflect the sound that comes from the stage to the people that are sitting. And the panels in the walls, by the walls, are the absorbent ones. So the sound will not come from everywhere in different times, because when it goes through different distances, it can go back in different times. Okay, we're going to talk about that in short.
Yeah.
Okay.
One quick tip, guys: if you want to test your space, the acoustics in your space, you can invite Sepultura to play into the space, and then you're going to see if everything's fine because they will test a space like this. Okay.
Do you want to you have sound barrier?
What are just really quickly? What are reflective materials? While I explain that, could you just? I'm going to put this link on private chat. Could you just put this on chat for them too,
all right,
please?
Cool. I will do a way to make this. Just a minute. I will take and present you guys.
I can put on the other chat too. What I want you to know is that reflective materials, they are those that have no pores, okay? So it's hard surfaces, like stones, or maybe like, sometimes wood can also reflect because it doesn't have pores. What else? Glazing is also very reflective. So no pores, very reflective, okay? Absorbent is when you have pores. It's fibers, it's hair. We are absorbent too, okay? So we have to take in mind the occupancy of the room. What else? all those materials that Sammy already told, they cannot be usually apparent in the room, but you have other ones that do. For example, curtains. All fabrics are absorbent because they have pores, okay? This website, I wanted to check later, please don't do that now, but this is for you to understand the difference in reverberation time and the difference in absorption of the rooms. So you have offices, you have train stations, you have libraries, and this article is very enlightening for you to understand this difference and for you to understand what the mass of the door plays, how does it play a role in the type of sound that you hear. And this is something very important too, because the author tells you that it's all about what you want people to feel in the space. Not every time you want to reduce the noise to as much as you can. Sometimes you want people to hear it. So in the New York Central Station, this is why you feel the life in the space, because there's so much noise that you feel that your life is going to change there. Okay, if you kill that noise, if you put too much absorption, then people won't feel that joy, that life in the space as they want to show you. Okay.
Yeah, exactly. This is underneath, right? Certifications that we talked about in the previous classes. We have this learning spaces, as I've said before, smaller than 556 cubic meters. Yeah, you can use this strategy. You can put acoustic panel, right, or elements that equal more than the area of the ceiling. So let me see if I have a picture of this. And if you have larger, of course, you have you need to follow some other strategies here. And I thought I had a picture, but think about this. You need to have these elements on the area of the ceiling. Of course, you can distribute in your space, but you need to have this NRC of 0.7 or more, right? 0.7 or more is going to collect more of the noise, and it's not going to make this big reverberation. All right?
Okay. So we can go further from the ceiling. You already explained that. So manufacturers, they do provide you that these are NRC value, okay? And you can also use the lead table to get the coefficient of absorption that you need for each type, okay, of material.
Yeah. You can see here, right, differences on types of materials and the coefficients of each one, so you can use this as a reference. Let me put you in just for 1 second. You can take a picture, and let's go on. All right.
And this is in comparison to the other graphic that we showed you before. And this time, when we talk about absorption, green walls are okay. So you can use green walls for absorption. This is the light green line that you see, and it's really good for low frequencies. So it's the sound of low voices, or not voices, but low sounds. How can I explain that? When you have subwoofer music, or when you it's this I don't know how to say it in English actually, but you have low frequencies and you have high frequencies. High frequencies is very high sounds, high in the music. So green wall would also help you with that, which is also really difficult to get from other materials. This heavy absorption of this low frequency. Okay.
Exactly. Let's proceed.
Bass. Thank you.
All right.
Bass. Yes, bass is when it comes to instruments, you can think of bass, but when it comes to animals, you can think of elephants, perhaps.
Yes. And important to have in mind, reverberation time is all about the volume of the room, as Philip said, and the absorption materials. Okay, they have this relationship, and you have to have that in mind. The biggest the room, the highest the volume, the biggest the highest the reverberation time. Okay,
yeah.
This is why in an apartment I have to have a reverberation time lower than 0.6 seconds, and in indoor stadium, for example, I can have from 1.5 to 2 seconds, which is the time that sound